Our solution: SAFFR-PA, Crane Collision Hazard Elimination System. Since the Mesopotamian times, cranes have been helping human race. They are an engineering marvel and have become integral part of warehouses, construction, industries and manufacturing sector. The handling and storing of materials use cranes for activities like lifting boxes and placing them on a car or a pallet, moving the pallets and goods, transferring products from one place to another and transporting raw materials from loading dock to the manufacturing. Handling of cranes can be dangerous and hence could lead to various hazardous events. These could occur as a result of human error, machine failure or both. So the question is, how can we eliminate such hazards? The first step is conducting a site survey. In this process, possible workplace scenarios and hazards are identified. For instance, workers who hook and unhook the crane bags work very close to these machines and they could be victim of collision hazard. Step 2 is estimating risks. We use risk graphs to estimate the risk levels such as severity, frequency and probability. For example, in case of a collision between machines and workers, the severity will be rated high. Frequency of operation can be measured as to how often the truck loads and unloads from the crane. And greater is the load weight, the larger is its probability to collide, and lower are the chances of being safe. Step 3 is ideation. Hierarchy of controls is being used as a means of determining how feasible and effective control solutions can be implemented. This hierarchy is based on the idea that methods on the top are most effective, while those on the bottom are least effective. Solutions at the top of hierarchy like elimination and substitution were found to be very expensive and cumbersome to implement, while solutions at the bottom like administrative control and PPE were too ineffective to be considered. Henceforth, our major focus shift to engineering controls which were found to be effective and adequate in risk elimination. But then one must have the question, how will this engineering control solution work? Our engineering control solution TRAKR PASS, pedestrian alert system, has each worker provided with a SafeMet, a smart safety helmet. PASS nodes are mounted at desirable locations on crane to interact with nearby SafeMets. With the help of these PASS nodes, distance from the worker to the crane is calculated continuously in real time, and whenever the worker comes close to the crane load, the crane stops. Step 4 is execution. In this process we execute the above analysis with the help of our solutions. As you can see here, the loaded crane hook doesn't move when the worker is standing near to an EOT crane even though the driver is pressing the button for moving. But as soon as he crosses the emergency range away from the danger zone, the machine starts moving again. When the worker stands near the load again, the machine again stops. Our solutions are finally tested for all sorts of challenges and scenarios in the workplace. Step 5 is removal of residual risk. We need to be sure that the worker or the operator is wearing the helmet while handling the crane. This process is called residual risk mitigation. Data from the mounted cameras are sent to TRAKR AI server via IoT integrated hardware called the TRAKR Video Analytics Module. And whenever a worker is not wearing the requisite helmet, an alarm can be raised or a message could be sent to the supervisor depending on the management. With such level of research, detailed analysis and execution, we ensure complete elimination of industrial hazards for heavy machinery like cranes.